Here we're going to be taking a look at techniques for solving 4 other kinds of equations. The technique here is not unusual. We have done this before. It's just how you implement it that is a little different. We look at the denominators of all of the fractions and decide what we need to multiply both sides by. So we know, since there's a 2 here, we have got to have a 2 so that they will cancel. Also, the x plus 1 tells us we have to have an x plus 1. Now those are the only 2 things in the bottom, so that's what we will multiply by. Now over on the left, when we multiply here, we've got to multiply both of these. Now I'm going to go ahead and write this out. Sometimes we can take shortcuts by not writing every single thing down, but I think it's good in the beginning that we do. So here we've got the x plus 1 times the 2 times the fraction 2x minus 3 over 2. Here we've got the fraction, we've got the x plus 1 times the 2 times the fraction 5x over x plus 1. And we still have the same plus sign in between. On the right, we don't have any fractions, but what we do have is the x that was already there times the 2 times the x plus 1. On the left, the 2's will cancel. That's why we put the 2 out there in the first place. We end up with x plus 1 times 2x minus 3. Now I'll go ahead and multiply that together. So we've got the x times the 2x, which is 2x squared, the x times the 3, which is negative 3x, the 2x times the 1, that's a positive 2x, and then the 1 times the negative 3. In the second fraction, we've got an x plus 1 and an x plus 1, and again that's why we put the x plus 1 out there. They disappear, and we get 2 times 5x, which is a 10x. And we'll go ahead and start doing some multiplying over here. We've got the x times the 2, which is 2x, times x, which is 2x squared, and we've got 2x times 1, which is 2x. Now it's just a matter of recognizing that we do have a quadratic, and so we'll get all of the terms on the left-hand side. That's our plan for solving a quadratic. So if we subtract the 2x squared from both sides, they disappear altogether. That's fortunate. We got some x's over on the left. Negative 3x plus 2x plus 10x is a 9x. And the only thing left on the right is the 2x. So if we subtract the 9x and divide by negative 7, we end up with 3/7. Now you sort of need to check your solutions when you're dealing with fraction problems, but mostly what we're wondering is that going to work in this fraction where we have x's in the bottom? And so 3/7 plus 1, I don't know what that is, but it's not a 0. So that should be the solution. Very similar to the previous problem. We need to multiply both sides by something. Here's an x minus 5. So we'll put x minus 5 on both sides. Now here, likewise, is an x minus 5, but we don't need to list it twice. So when we multiply here, we would have an x minus 5 and x over x minus 5. X minus 5's will disappear. Here, nothing cancels, so we just have an x minus 5 times 5, which, when we multiply here, is a 5x minus 25. And on the right side, the x minus 5's disappear, and we end up with just the 5. So we can put the x's together. We can add 25 to both sides. And finally divide by 6. Now, like the previous problem, we want to check. And as I mentioned in the previous problem, basically we're interested in whether or not that even works. Well, if you look here, we had an x minus 5. Well, if you put a 5 in place of the x, you got 5 minus 5. So that's a 0. And you can't have division by 0. So anytime we get an answer that would make a 0 in the bottom of any of these fractions, we just discount that answer, though there's no solution. Notice that in the fraction on the right, we have x squared minus 3x, which factors into x and x minus 3. So when we start deciding about our common denominator, we know we need an x minus 3. We know we need an x. And when we get over here, we already have the x, so we don't put it a second time. And we already have the x minus 3, so we don't write it a second time. So now it's just a matter of going through those multiplications. I alluded to this in the first problem. I'm going to go ahead and write my arrow here so that I know I'm going to be multiplying these two. Well, when I multiply those two, the x minus 3's are going to cancel. Now, I'm not going to mark it out. As you'll see in just a moment, it needs to be there for the next thing that we do. But in my mind, I'm just saying, well, those x minus 3's are gone. That leaves me with an x and an x minus 5. Over here, I'm going to draw my arrow so I'll remember this is what I'm doing. The x in the bottom and the x in the front are going to cancel, and we'll have a 1 times x minus 3, which is just x minus 3. And then on the right, you don't need to do that because there's not a plus sign. We just mark out the x's, mark out the x minus 3's, and the only thing left is the negative 7. So this becomes an x squared minus 5x plus x minus 3 equals negative 7. Since we have an x squared, we need to collect everything on the left-hand side. We can put the x's together. Negative 5x plus x is negative 4x. And if we add 7 to both sides, negative 3 plus 7 is positive 4. And so now we need to solve the quadratic. If you have the quadratic formula program on your calculator, that would be a quick way of doing that. This one does indeed factor, however. Two things that multiply to give a 4 and add to give a 4 would be 2 and 2. Same sign, that being a minus. So x minus 2 equals 0 gives x equals 2. And so As long as that doesn't make zeros in the bottom, we're in good shape. So if that were a 2, that'd be 2 minus 3. That's not a 0. If that were a 2, well, it'd be a 2. That's not a 0. If we had 2's in place of these x's, that would be 2 squared is 4, minus 6 is negative 2, and everything's fine with that. So again, I won't bother doing all the individual calculations. We come out with the answer, x equals 2. Practically just like the previous problem, we're going to start by factoring. Then we'll write our common denominator out here. That's going to be an x plus 5 and an x minus 5. And we already have x plus 5 and x minus 5, so we don't need to write them a second time. Now again, I'm just going to mark this and recognize the x plus 5's are going to disappear, leaving an x and an x minus 5. The x minus 5's in this second one are going to disappear, leaving us a 5 and an x plus 5. And in the one on the right, we can go ahead and just mark out the x plus 5's, the x minus 5's, and the only thing remaining is the 50. So here we have x squared minus 5x. Here we have 5x plus 25. The negative 5x and the positive 5x are going to subtract out. When we subtract 50 from both sides, we end up with x squared minus 25 equals 0. Now we can solve this by a technique we learned earlier, where we move the 25 to the other side and do the square root of both sides. Remember the plus and minus. So again, these are the only two answers that show up when we do all the stuff that we are supposed to be doing. So let's investigate those. If we take the 5 and recognize that if we put a 5 here in place of that x, we'll have a 0 on bottom. So we cannot have the 5. Likewise, if x was negative 5, this would give a 0. So again, we can't have a negative 5. Since the only potential answers are gone now, that means there is no solution. Now we're going to change and look at some different equations for a while. In this one, we notice here is a square root. When you have equations involving square roots, the trick is to get the square root part by its little self, which we can do by adding that to both sides. So that disappears. And we end up with just x equals, and then the square root of 4x plus 12. Now we will square both sides. On the left we have x squared. On the right, the square of a square root just wipes each other out. And since we have a quadratic, we will gather all of our terms over on the left and then finish the job of solving, which again, I would typically just use my quadratic formula program on my calculator. I'm pretty sure, however, that we will find that this one likewise factors. Two things that multiply to give a 12 and subtract to give a 4 would be 6 and 2. That minus tells us they have to have opposite signs with a negative on the larger. So we set each of those equal to 0 and finish solving. Now, in doing the square roots, we really do need to check our square roots and see if everything is working. So, if we use a 6 in place of the x, we get 6 minus the square root of 4 times 6 plus 12. Now, 4 times 6 is 24, and 24 plus 12 is 36. Square root of 36 is 6. 6 minus 6 is indeed equal to 0, so that checks. Negative 2. So here's negative 2 minus the square root of 4 times negative 2 plus 12. 4 times negative 2 is negative 8, plus 12 is 4. The square root of 4 is 2. And negative 2 minus 2 is not 0. That one does not check. X equals 6 is the only one of those two that works. So that's the answer. We'll use a similar process for this one, but it does require a lot more work, so pay careful attention. We are going to fix this where both square roots are not on the same side. That will make it a little bit easier. So we will add the square root of x plus 4 to both sides, and that will disappear. So we have square root of 3x plus 1, and this is 1 plus the square root of x plus 4. We will square both sides, just like with the previous problem. And just like with the previous problem, the square and the square root wipe each other out. However, what we have over here is a binomial. The way you square a binomial is you square the first term, you square the second term, leaving some space, and you multiply these two together and double that. 1 times the square root of x plus 4 is the square root of x plus 4. You double it and you get 2 square root of x plus 4. So you got to be careful about how you multiply these out. Now we will do again the same process. We'll get this square root by itself and then square both sides. So if we add the 1 and the 4 together, that would be a 5. I'll go ahead and write that down. We will subtract the x from both sides. That'll leave us a 2x here, no x's here. We will subtract 5 from both sides. 1 minus 5 is negative 4. And now we want to divide both sides by 2. So we end up with the square root of x plus 4. And here, remember, we have to do both of these together. 2 divided by 2 is 1x. 4 divided by 2 is 2. When we get the square root by itself, we square both sides again. The x minus 2 squared, we just went through this in the beginning, is x squared minus 2x doubled, and negative 2 times negative 2, which is positive 4. And the square and the square root just wipe each other out. And so we need to subtract x from both sides. And subtract 4 from both sides. They're going to both disappear. We can factor this and set each of those equal to 0. And as usual, we need to check to see if those actually work. So if x is a 0, we got the square root of 3 times 0 plus 1, that'd be a 1. The square root of 0 plus 4, that'd be the square root of 4. And so this is a square root of 1, which is a 1. Square root of 4, which is a 2. Is 1 minus 2 equal to 1? No. 1 minus 2 is negative 1. So we're going to chunk the 0. Let's try the 5. So if we've got the square root of 3 times 5 is 15 plus 1 is 16. And the square root of 5 plus 4, which is 9. Square root of 9 is going to be a 3. So we want to know, is 4 minus 3 equal to 1? Yes, it is. So there's the only one of these two that work out. On these next ones, we're going to be dealing with rational exponents. That's a fancy word for fractions. And the trick is to take the x to the 3 halves and the 2/16 and raise both of those to the power 2/3. You notice what that does. 2/3 times 3 halves comes out to be 6/6, or just x. So again, we raise both sides to the 2/3 power. Now you can type the 2/16 to the 2/3 on your TI calculator. You don't have to do that by hand. If you need help with that, you're going to need to contact me for it, because I'm not going to pull up the calculator and do it here. However, sometimes, as you'll see in the next one, we have an exponent such that when we flip it, like we're about to do, we get an even number on bottom, which is like square roots. Meaning, could be plus or minus. I mean, we're basically doing the square root. If we do something to the fraction that has a 2 on bottom, we're doing the square root. Plus, we're going to have to remember to check our answers. So again, over on the left, that just comes out to be an x plus 7. On the right, we get the square root of 4 raised to the 5th power. So that's 2 to the 5th power, which is 32. If we take 32 and write us an equation with the 32, and then the negative 32, and then finish solving. If we subtract 7, we get x equals 25, and if we subtract 7, we get x equals negative 39. Now again, we want to check these and see if they actually work. If we take the 25, plug it in, we get 25 plus 7, that's 32, to the 2/5 power. Now again, you can do that on your calculator You don't have to do it in your head. And that does indeed come out to be a 4. So this one works. If we take a negative 39, we have negative 39 plus 7, which is negative. I'll go ahead and write it down. That comes out to be a negative 32. And again, you can type that into your calculator. The fifth root of negative 32 comes out to be a negative 2. And negative 2 squared comes out to be positive 4. That one likewise works. The last technique I'm going to show you on the next couple of problems is called a substitution. What we're going to do is we're going to replace the x minus 3 to the 1/2 power and the x minus 3 to the 1/4 power. We'll start by using the x minus 3 to the 1/4 power as x. Well, let's call it some other letter. How about we use a t besides an x? So we're going to be replacing the x minus 3 to the 1/4 power with a t. So that'll be a 6 and a t. Now notice, if we square this, that means that x minus 3 to the 1/4 power squared, which happens to be x minus 3 to the 1/2, comes out to be a t squared. Now that's kind of the key to the whole process. So this is going to be t squared minus 6t plus 8. Now I can solve that. In fact, I'm pretty sure that that factors two things that multiply to give an 8 and add to give a 6, 2 and 4, same sign, negative on both. T minus 2 equals 0, t minus 4 equals 0, t equals 2, and t equals 4. Now we go back to what we did in the beginning and change the t back into x minus 3 to the 1/4 power. Yeah, I didn't mean t, I meant 2. And likewise, and then we need to finish solving. I'll change colors. Raise both sides to the 4th power. That comes out to be a 16 and an x minus 3. Add 3 and we've got 19. Same thing here. Both sides raised to the 4th power. And add 3. Now I'll dispense with the checking. I think you can see that there's not going to be any anomalies with these two numbers. So in this last one, we're going to do a technique very similar to the previous problem. We're going to take the x to the negative 1 and x to the negative 2 and replace them. We'll use a t for x to the negative 1, which would make x to the negative 2 a t squared. So the equation becomes 15t squared minus 4t equals 3. We move the 3 over to the other side, we get 15t squared minus 4t minus 3. And if we factor that into, say, 5t and 3t, and maybe 1 and 3, then we need the products here, 9 and 5, to subtract to give a 4, which it does. So that's the right combination. We also need a negative on the larger product, which would be the 2 3's. So 5t minus 3 equals 0 means 5t is equal to 3, or t is equal to 3/5. 3t plus 1 equals 0 means 3t is a negative 1, or t is a negative 1/3. Now remember, we're not finished. We need to come back to what we did in the beginning and rewind that. So we'll replace the t with x negative 1, and finish solving. Now to finish solving, we can do this. We can raise both sides to the negative 1 power, because negative 1 times negative 1 is positive 1. And that'll give an x. Now again, you could type this on your calculator. I'm getting ahead of myself. You can type this in your calculator, 3/5 to the negative 1 power, and see that just comes out flipped. And likewise, we don't need to bother checking those answers.